In the comments of my 3 Super Mario Odyssey videos, and on Twitter, and pretty much everywhere, people have been asking me to release the code for these projects. So in this video, we're going to be taking a deep behind-the-scenes dive into that code. But first, of course, if you haven't seen these videos yet, you should definitely watch them first. There should be links in the description. Otherwise, the rest of this video will make no sense. But also, before we get into the actual code, I want to talk about my reasons for not releasing the code, at least not widely until now, and the motivations behind people asking for the code. So you've probably heard this line before. Oh, this code's too messy, it's embarrassing, I don't want anyone to see it. Oh, maybe one day I'll clean it up and I'll release it. And yeah, that sort of mentality is certainly applicable here. Because sure, I'm sure most programmers understand the concept of clean code. They realize the benefits of writing code that is easily understood by others. But actually, writing clean code is not a trivial task. Naming things, for example, like variables, takes some mental effort. It's much easier to just write down the first thing that comes into your head. And especially when you don't expect anyone else to ever actually look at your code, it's very easy to get, well, extremely sloppy. Of course, that's misguided. Like, even if you're the only person that's ever going to look at your code, you're still going to have to read it. Whether that's 5 minutes from when you wrote it, or 5 months, writing clean, readable code is important for your own sake, if no one else's. My hope is that what those people will get out of this video is say, oh, here's the libraries he used, here's how to use them, here's an idea of the techniques I could use if I wanted to code this sort of thing myself from scratch, which is what I would hope people would do. Although, I should warn you, remember that these projects are about 6-7 months old. There's a whole world of Switch reverse engineering, homebrew emulation, all that good stuff that I haven't kept up with. I don't know what the state of the art is in that regard. It's entirely possible that there are newer, better ways of doing the things that I did. So just keep that in mind. And the other group I'm worried about is people learning programming. Those hoping that they'll be able to look at my code as an example of what to do, and hopefully learn something from it. That's the exact opposite of what you should be doing with my code. This is going to be very much a lesson in what not to do. So hopefully, this will be, to some degree, an educational experience for at least someone. Anyway, with that out of the way, let's take a look at the actual code. And for that, I have a very special guest, my friend Jordan, who is a professional software developer. Jordan, tell them about your credentials.
I'm here to make Jacob feel bad about himself.
Yeah, that's why Jordan's here. But before we get to the actual code itself, so first, the library I used, the main one, the one that's doing the actual input emulation on the Switch. That is this Switch Fight Stick library by one Progman, which itself uses the Lufa library. Now, I don't know much about the Lufa library, and I don't really need to. All I know is that this code does a pretty good job of turning a microcontroller into something that the Switch thinks is a hoary fight stick. And as far as games are concerned, that's a Pro Controller. Now, this Switch Fight Stick project didn't really catch many people's eyes, but what did was this, Shiny Quagsire's fork, the Splatoon 2 printer, which some of you might have seen people use to create those intricate drawings in Splatoon with their fake Miiverse thing. So this is the code from that project. As you can see, it's written in C. Haha! So this is the... And basically, I took this code and modified it in the laziest way possible. So down here, you see, starting at line 196, we've got this giant switch statement, right? And so this switch statement is basically a state machine that Shiny Quagsire used to make the Splatoon 2 printer. So you have different states like moving X, moving Y, stopping, starting, all that. And this is all inside a function that gets called every time the switch pulls for an input. So anyway, for this type of use case, we have a function that's getting called repeatedly that needs to store some sort of state. Naturally, a state machine is a good fit for that kind of purpose, which is why Shiny Quagsire used it in the first place. I, being a lazy programmer, did as little as necessary to modify this code to suit my needs. So basically, it goes through the state machine long enough to sync with the Switch. So, when you connect a Switch controller wired, you press the L and R buttons to say, hey, I'm here, and then you press A to exit out of that menu. That's like, hey, you got a new controller. And so then once that process is completed, the report count variable will be incremented above 100. And all we do is we set the state to wait UART. Now, wait UART is an extra little case I added, which just never changes. right? Like, the idea behind a state machine is, you're changing states based on conditions. Once we reach wait UART, we just wait here forever. Any comments?
Yeah, it's kind of dumb.
Thank you. So anyway, wait UART has this UART get care function.
Why do you have a state that's just that forever instead of just using the state machine the way God intended it?
Because I never change state. I mean, it makes sense if you think about it. Like, this is just the final state of the state machine. I mean, really
okay, I guess.
Really what I should have done is just rip out all of his code and replace it with something that actually suits my needs. Yep. But I'm lazy, so I didn't do that. I just took his code. Basically, when you have a hammer, everything looks like a nail, and I had a state machine. And so, I'm not sure how to end this analogy.
Everything looked like a state?
It's technically a state. It is a state. This is more of a state than not nail is a nail. Yeah, I'm good at analogies. I'm an expert. I am a professional software developer. Jordan?
Ish. Close enough. They do pay him for it.
So anyway, this UART get care function is part of some UART library that I downloaded off the internet. Because that's what you do when you're coding. You try to write as little code yourself as you possibly can, and anything that you can get from a library, you are very happy about. And so this version of the code that you're looking at, this is, I believe, actually the version from... Wait, no, I don't know what this is. Oh, no, actually, we do use states. I forgot about that.
Oh, yeah, it does look like it. So, yeah.
Yeah, because...
Why doesn't press Y have an _2? Is that your fault, or is
Well, PyCharm's yelling at me about it.
Okay.
Yeah, that's my fault.
Yeah.
Where's... Press A. Oh!
Nice.
So as you can see, we get the data from the UART, and UART is just like a protocol for communicating with microcontrollers. You just buy some cheap adapter like this. One end connects to your computer, the other end connects to your microcontroller. You can probably get them for cheaper than this and with higher reviews, but this is the first result on Google. So anyway, we get 1 byte from the UART connection at a time, and that's coming from the Python script that we're going to look at later. And we just have this giant if, else if thing. Could be a switch case, but whatever. I don't really care. And depending on that, we do different things. We set... What is report data? I don't know what this syntax...
You tell me.
Is it a struct? Is this like struct syntax?
Maybe. I don't know. You know how long it's been since I coded anything in C?
Have you ever made a struct?
I think I had to once, but probably only once.
Okay. So this is actually the slightly older version of the code, I think, that didn't have support for analog, right? So you see we just get commands like up, down, left, right, and it writes to this report data struct. Structs. It doesn't like structs. These are just constants that are like 255 or negative 255 or whatever for like the analog sticks. And then we just have these magic numbers here for like up, left, up, right, down, left, down, right. And you see I have comments for those. But then we get to this interesting case where if C equals B, if C equals B, we set the state to press A. And then in press A, we press B.
The inner machinations of his mind are an enigma.
So anyway, this button member of report data, it's just the element of a struct that's like this bit field, and then you OR it with switch B, which is just like 0000100, something like that. You know, the actual details of how this C code works, it's not super important. And then we set the state to hodl, of course. Hodl. How do they pronounce that? You're an expert.
Hodor?
You're a Bitcoin expert, right?
Yeah, you could say that.
Or it just waits for 5 milliseconds and then returns here. Everything returns here. And then this is just shiny Quagsire's code again. None of this ever does anything. And so that's basically this end of the code. Like, there's some extra boilerplate for setting up the UART library, but like that's it. There's not really much to see here, and already it's very poorly coded. So again, it's a learning experience, but you're not do as I say, not as I do, right?
Yeah, that's pretty good advice with him.
Oh, really? You do what I say?
Sometimes. Definitely not as he does. We're going to look at code in an actual programming language now.
Yeah, Python. It's great, isn't it? Okay, so with that C code out of the way, we can start to take a look at the Python code. And this is where we start to get a real appreciation for my folder structure. See, competent programmers, like myself, like my current self, not my past self, they like to store their programs on some sort of version control software, like Git, right? You've probably heard of GitHub at the very least. We were looking at it just a few seconds ago. And Git does a lot of nice things for you, but, you know, its highlighting feature, being a version control system, is managing different versions of a project. If you're not using a version control system, well, then you have to come up with folders and duplicate files, and I'm sure everyone's been down that road of having final.docx, final2.docx.
Or, you know, Mario Jumpio.
Okay, so my folder structure here. So yeah, we have this Mario, well, the entire folder is called Mario Jump, which is not a great folder name, but it's at least descriptive, right? And we have this Mario Jumpio folder. Well, Code Deep Dive, I just made that. That's this video. And we have Mario Jumpio, which has the Switch Fight Stick library in it and nothing else. I did not use that folder. And then the Mario Ballio folder. You can see how, like, jump rope, volleyball, except actually everything's in Ballio. Actually, no. Jump rope, I think jump rope is in Ballio. And then Mario Ballio for real, that, I think, yeah, this has volleyball. But then Mario Ballio for real analog way. I think that's the analog version of the volleyball version of the volleyball there.
You're really good at coming up with names.
I know, I'm so good. And then we just have an extra copy of Switch Fight Stick Master, just cuz. And then TaskBot. TaskBot is YouTube Plays. That's a better name, at least, right? It's not the most descriptive.
Take it over Mario Jumpio.
What about Mario Ballio for real analog way?
I mean, that's pretty descriptive. If you really get kind of high and, you know, think about it a little too long.
Did just come from California, after all. And then we've got the UART library, which I did not write. So we've got all these extra files here. I don't know what any of them are, really. We've got test.py, which, this is just writing garbage data to the serial port, I think. We've got video.py, which I just made a lot of test files and I duplicated them, and it's not good version control, right? Like that's the thing Git gives you, is an actual way to manage your versions of your different files. But anyway, jump.py, I'm pretty sure, is the actual jump rope bot. And so we can start there. And where better to start than line 1? Import numpy is np. That's good practice, right? You only want a nice little abbreviation.
Sure, I guess.
Yeah, that's fine. Import CV2, that's OpenCV, which does nice image processing, and it'll handle webcams and stuff like that. I'll talk about the capture card later. There's the serial library. I think that's part, well, it's apparently not part of the standard library, since PyCharm is mad at me. I didn't actually use PyCharm when I wrote any of this. I just used Notepad. Notepad++ at least. But you should use an IDE. IDEs are good, and they love you, especially JetBrains IDEs. Not that I'm a shill or anything. Time, I probably sleep at some point, and then WinSound is unused. See, if I were using an IDE like this, it would tell me when I have an import that's never used, but I didn't. So this import's just sitting there, and like that's fine. You know, it's not hurting anyone, but it's messy. So then we've got some constants. Constants are a good thing to have in your code. It's like you don't just want to have random numbers like 2500 and 33 scattered about the code, because like what does that mean? And you know, if you have to change it, then you have to change it everywhere. So it's good to have constants like this. What do you think of my constant names, Jordan? Frequency and duration.
Of question mark?
Right. So I say frequency, right? But that variable name doesn't really tell you frequency of what or duration of what. These are very generic variable names. And it's like probably when I was writing this, like frequency, yeah, that made perfect sense to me. But now 6 months later, I'm going to have no idea what that means until I continue reading this code. And also, this is more of a style, convention sort of thing. But typically, people make constants all caps. I mean, maybe they don't do it in Python. I don't really follow standard style convention guidelines. But it's nice to make your constants all caps, so you know they're constants. They're not going to change, right? Like this constant down here, that's all caps. That's a, never mind. Okay, Jordan, what do you think of this variable? Prim equals none.
It looks very descriptive because I definitely know what prim is.
What does prim stand for? Can you at least guess what prim stands for without looking at the rest of the code?
Perimeter. Primary.
I think it's primary. Because I looked at this code a few months back when I was working on the YouTube Plays video. I think it stands for primary. But we're going to find out. And then cooldown. PyCharm is mad about the word cooldown because it doesn't have it in its dictionary. I think this is an okay variable name. I would put spaces around that equal sign. Yeah. But other than that, I think cooldown is an okay variable name.
I can live with it.
And then what do you think of this?
Ooh. Why?
So Python does not need semicolons. You'll notice that there is a semicolon at the end of this line.
Everything's better with a few semicolons thrown in.
Yeah, whoops. Not there, though. Yeah, let's just add some semicolons. So a lot of people might not...
I'm not a huge fan of that.
Oh, does it not like multiple semicolons? Yeah, interesting. So yeah, a lot of people don't know this, but Python is actually perfectly happy if you end your line with a semicolon. You just shouldn't, because, like, why would you? It's not necessary. So anyway, the rest of the code is all inside a giant try block. And I know some people are going to give me some shit for that. But if you look at the end of the try block, you will discover it is not a try catch. No. It is a try finally. And in the end, we close all the things that we open in the try. We'll get to that. But that is good practice, right?
I mean, there are worse practices. It's closing everything is good.
Yeah, so these are things like sockets and the webcam and then like the windows, right? So that's what we're doing here. That might not be necessary, like when the process ends, those things will probably end, but you never know. Like, what if you open a file and then the file never gets closed? And then it's just lost in purgatory forever.
Like maybe pull something out into a function, make your try.
Oh, there are no functions
here. A little shorter.
There are no functions here.
Yeah, I know. That I'm trying to point that out.
Anyway, so we've got some boilerplate here. Cap is, so CV2.video capture. So this is one of the nice things about OpenCV. It's got this nice method built in for reading video from a webcam or a generic video capture device, which is what my capture card is. Now, a lot of people ask me specifically, like, what model number is your capture card? And, like, trust me, you do not want to buy my capture card. It's like 10 years old. Maybe not 10, but it's pretty darn old. It's this old PCIe AverMedia capture card. If you really want to know, like, what specific model number it is, I mention it in one of my previous videos, and you're going to have to track it down yourself. It's another behind-the-scenes video, though. It can't be that hard to find. But believe me, this is not the capture card you want to buy. It only supports 1080i, and even then, at 1080i, you get a bunch of latency. So really, you can only set it up to 720p. And it certainly doesn't support 4K or any of the fancy new things. But really, the nice thing about this card, because it's a PCIe card, it's got nice low latency. Now, I don't know what the state of the art these days is in capture cards. I know back in the day, like USB 2.0 capture cards, especially HD ones, would have horrible latency. Maybe these days with USB 3.0, they've got nice low latency and stuff. But I know the Elgatos all have like HDMI pass-through. Like most of the time when you're using a capture card, like you don't care about the latency, right? Because you're not going to be playing it in the preview window. It's only, either if you want to do that, if you want to play a game or using your computer monitor as a TV, or if you want to do something like this, using it programmatically, that you actually care about latency. So if you're looking at buy a capture card specifically for a project like this, that's the most important thing, is just low latency. So that's what you're going to want to look up. Low latency HDMI capture cards. What do you think of this cap variable? I probably stole that variable name from whatever tutorial that I learned how to do this in.
It's bad, but so long as it's short for capture, it's not the worst thing in this code.
Yeah, and then we have SIR, which is short for serial. That is the object representing the serial connection, which is on COM6. So that's the thing. Like, people say, oh, just give me my code, and, like, I'll just run it. And it's like, no, you're not. You have to have a 720p HDMI capture card set as your second webcam. And I think that's actually the third, because it counts from 0. And you have to have this USB UART thing connected on COM6. So it's already Windows only. Like, it's very specifically configured for my computer, among other things. Then we have B equals N. What do you think of that?
I think you need help.
So yeah, a single letter variable name like this is basically the worst thing you can do. Like there are certain circumstances where it's okay, like in, a math formula, right? Like if you're writing the quadratic equation, no one's going to yell at you for using A, B, and C as variable names. But this B, like what the hell does B mean? What the hell does B mean?
Is that like a binary N?
Yeah, so this B is binary because this is Python 3. Right, so the B makes it a bytes rather than a Unicode string. Does that make sense?
I mean, maybe if I knew why you were doing it.
It's because we're doing serial stuff. It makes sense.
Where does B do anything?
We'll get to it.
Someday?
Someday.
Okay.
Anyway, that's why that B is there, because bytes. Bytes are good. We like bytes. I think B might stand for bytes. Or buttons. It might stand for button. I think it stands for button.
The fact that you have to wonder.
I wrote this code.
Yeah.
That was like 8 months ago. That's the thing. Like you think, oh, I'm writing the code. I understand it. But then 8 months later, you come back to it, and you're like, what the hell is a B? It's been so long since I used Python. I don't even remember what this means. It makes it a bytes. So anyway, so we do this. We call this function cap.set. Notice we initialize cap up here. Then we do all this other stuff. And then we continue initializing cap. And we also wrap this in these print statements, which makes it kind of hard to tell that these method calls are actually doing something. But they are. They are setting properties 3 and 4 of the cap object to 1280 and 720 respectively. Now, I blame OpenCV that this is so obtuse because this makes no sense. But there are things I could do to make this better. I could have constants or something. But also, this is just like boilerplate. What's your thoughts?
What does that print? That's my thought.
I think it prints like 1 or like true.
Why do you print it then?
So I know it works. I don't know. It's just so it like does something, so it prints something.
Well, but the issue here is that it is doing something, but you're making it look like it's supposed to be returning something when you don't care. Something to think about.
I mean, it returns like success or failure. Like I could do something with that success.
Yeah, but
instead of just printing it. But yeah, this isn't great. But
I agree with you on that.
Oh, yeah, PyCharm's mad because these parentheses don't actually do anything because it's Python, and Python loves you, and Python doesn't make you type parentheses when you don't have to. So anyway, everything's in this while true loop because this code runs forever. That's fine. There's probably a break in here somewhere. Yeah, down here. This is like standard stuff. This is fine. So anyway, ret and frame equals cap.read.
What's a ret?
Ret is never used. So anyway, cap.read, that obviously just reads the data from the video capture, and clearly it returns a tuple. So if you've never used Python, tuples, learn what tuples are. Basically, we unpack that tuple into these variables, ret and frame. And frame is what we actually care about. Ret is never used. But the fact that ret has a name might imply that it's meaningful, that name actually means something, this variable actually does something. So standard Python practice, if you just need a dummy variable for something like this, like tuple unpacking, is to use an underscore. Because you're never going to use an underscore as a real variable name. So this is standard practice. I just stole this from a tutorial or something. So that's why it's called ret and frame. Probably stands for like return.
Yeah, that was my only guess.
Just still a bad variable name.
Yeah.
I mean, you can't call it return because that's a keyword, right? Yeah, it won't let you do that. So they're just like, yeah, we'll call it ret because it returns something. I don't know. So anyway, S. What does S stand for?
Screen.
I think it stands for score because we're cropping here. So this is just like, list indexing in Python. I think this is a NumPy array, so you can do like this fancy comma stuff. And I think we're just cropping the frame, which is, the entire 720p video image, down to the little score display thing, the part we care about. I think we're calling that S for score.
Maybe just call it score.
We could do that. And yeah, there's some magic numbers here, but like they're only used once, and they're numbers you just kind of fiddle with. So anyway, we convert S to grayscale, right? Because we don't actually care about the color information. We just want to see when S changes. And here's our good buddy ret again. Again, PyCharm's mad because we're redefining ret even though we never used it previously. But that's because we're never going to use ret. This is a different ret. So we're calling a different function cv2.threshold. And this basically just applies like a threshold, which is like, okay, so if the grayscale value is between 200 and 255, in other words, above 200, then it's black, otherwise it's white. Because, we don't actually care even about the specific grayscale values. We just care when the pixels change. And you'll notice there's these commented outlines here, where I was like just trying out different things, like, oh, what if I apply a blur here? What if I do a denoising here? What if I do a blur here? So, I was having those issues with noise and stuff, but I commented those out. Again, if I was using version control, I could just delete those lines and be confident that they're still safe and happy in version control if I ever need them. But, when you're just debugging, just commenting out a line for a second or two is fine. The problem is when those comment out lines stay there forever, which is more of a problem in like a big software project. This thing is 50 lines. It's like, I'm not too concerned about that. It doesn't really hurt the readability in any meaningful way, but it's just not great practice to have those there. So if prim is not equal to none, remember prim?
Vaguely.
Prim is none.
Okay.
So this if doesn't get executed yet. Remember, we're in a while loop, so we'll be back here. And so if b is not equal to n, b is n. So, whoops. So this doesn't get executed yet. Our operations on the frame come here. I probably stole that comment. That does not sound like a comment I would write.
Nope.
I wouldn't use the word hour for one thing. This line is just like this line, but with gray and frame instead of S. That does nothing. Cooldown, we've got this cooldown. Remember cooldown? Cooldown equals time. Wait, what? Cooldown equals time.time. Time.time just returns like a time object that's like now. Okay. Or maybe it's like an int. It's a float, which is like the Unix timestamp or something. So we add 1 to that.
Okay.
That'll make sense later, I'm sure.
Sure.
All right, so then we have these two imshow method calls. These just display those little windows so I can see the game, And we display frame, which is just everything, and then S, which is the like little cropped out image processed version that we've got. And so I can see like what all this image processing is actually doing in real time, which is kind of cool. And then this is just standard boilerplate for OpenCV window stuff. If you don't have this, it'll like break. And it's just like, okay, if you hit Q, then close the thing. So then prim becomes a copy of S. Maybe prim stands for primary and S stands for secondary. Because I think we're going to be comparing these two later. Because remember that's how the jump rope bot worked. So you would see when the score display changes. Uh-huh. So we're going to be comparing prim and S. So it makes sense if it was primary and secondary.
I guess so.
So why did I abbreviate them to different numbers of letters?
Because you're you. Because you're special.
I am special. So anyway, when we go through the loop again, this time prim is not none. And so this if statement gets executed. Oh, diffo. Diffo, you like it when I end variable names with O unnecessarily?
Oh yes, I love it so much. It really helps me understand what the variable is trying to do when you just kind of put O at the end.
There's a typo in the word diffo. I'm going to save diffo to the project level dictionary.
Maybe don't do that.
Diffs, daffy, db info. All good suggestions. I'm going to rename it to db info. I'm not going to do that. So anyway, then we do some math on arrays. So that's why we're using NumPy methods. So we subtract prim from S, and that's like a matrix level subtraction, right? So it's, element by element.
Yeah.
Then we take the absolute value of that, which I think just isn't an element by element absolute value. And then we sum it. So I think that just adds up every element in the matrix, or the array, or whatever you want to call it. That'll make sense, right? That sounds like how you would find the difference between two arrays, right?
Yeah.
And so, like, the bigger this number is, the more of a difference there is between S and prim. So, like, if S and prim are the same, theoretically this should be 0. But it's not, because there's some noise in the signal for some reason. I don't know why. Maybe it's because it's being downscaled to 720, and the game's natively higher than that, or it has, like, temporal anti-aliasing. Or maybe there's just some noise in the signal, because, like, I'm using this long HDMI cable and this, like, really old capture card. I don't know why that noise is there, because, like, it's a digital signal. Like, it's not analog noise. But anyway, and then we divide it by 1,000 because I don't like big numbers. I prefer small numbers.
Oh, well, good for you.
So we divide it by 1,000 just to make me happy and to waste CPU cycles. Like that's just whatever. It's unnecessary, but it's not hurting anything.
You certainly wouldn't want to have any big numbers that would make you uncomfortable.
Yeah. And then we print it. Maybe that's why, because then we print it, and so I can instantly see, oh, is it a 1-digit number or a 2-digit number? Because that's like, oh, 2-digit number, that's a big boy. But like the difference between a 4-digit number and a 5-digit number, that's not as obvious, right? That makes sense.
I guess.
Yeah. It's because I'm printing it. So anyway, we have this threshold. It's got to be 4.7. That's the magic number. I just had to figure that out, tweaking it, finding the perfect number to, not get triggered by noise, but to actually get triggered when the number changes. So I like to do this sometimes when I'm just like prototyping, is just sticking a comment in the middle of a line and then like cleaning up the syntax. So this used to be an OR, and there used to be this cooldown based on a timer. It was like 36 frames. Cooldown plus equals 1. But that code doesn't work anymore, obviously, because it's commented out. And so clearly cooldown is just not used anywhere. It's assigned in multiple places, but then it's just never used in the final code. Then we print /A. You know what /A is?
I do not.
It's the bell character. That makes it ding at you.
Great.
So I never posted well, look at the next line, time.sleep, for 23.2 frames, right? 60 FPS. And so it just sits there doing nothing. So I never posted the full archive. It's like I recorded this whole thing of it doing the jump rope thing to get 55,000. I recorded that, but I never posted it. And this is why. Because it just sits there. Every time Mario jumps, it just sits there for 23 frames. And it never gets here, right? So the video just freezes while it's waiting until it presses the button again. And it also dings every time he jumps. So it's a really annoying video. No one would want to watch that. And then we set B to B. B equals BB. That's a really good line. I really like this line.
I really don't.
It's just complete nonsense. Like, if you don't have all this context of, like, if I just sent you this line by itself, not saying, hey, this is Python code, or B is a variable or anything like that, if I just said B equals B quote, like, what the hell does that mean?
It's a good question.
It wouldn't even look like code. So yeah, we set B to B. And, like, clearly B is the button, is the variable that stores what button you press. And if it's N, if B is N, right, well, we're about to get there. So anyway, yeah, if it passes this threshold, then we set B to B, which makes Mario jump. We set cooldown, which does nothing. If we don't hit the threshold, then we hit B to N. And then we get to this block of code where if B is not N, N stands for nothing, then we write B to the serial port. And that goes out to the microcontroller, and the microcontroller is like, hey, I've got an input, press the B button. And that's the jump rope bot. It's actually pretty simple. Only 50 lines of code. It was just a lot of tweaking to find, like, this number and this number, and to get this thresholding right. But other than that, the logic's pretty simple. It's just very poorly written.